To the 2021 NASA Earth Science Applications Week. This week, we'll celebrate the many ways that NASA Earth Science helps make our world a better place, and celebrate the official 20th anniversary of the NASA Applied Sciences program. Thank you so much to all who are joining us from across the globe. My name is Katie Lang. I'm a fellow with the NASA Developed National Program at the National Centers for Environmental Information, and I will be your MC for our first event this week. I'm so glad you've all joined us for our second virtual event of this scale. This year, we're happy to report that we have an even larger turnout with over 800 registered attendees joining us from 65 countries. We hope you all are as excited as we are to jump into a week full of engaging events, including project highlights, guest speakers, expert panels, and interactive group discussions. You can find the complete agenda and links to all events on the NASA Earth Science Applications Week event webpage, and should any changes occur, the most up-to-date schedule can be found here. For a brief summary, we'll kick off each day with plenary sessions from 12 p.m. to 2 p.m. Eastern Time on Zoom, using the same link that you used to join us here today. And following the daily plenary sessions, we'll have networking socials on Monday and Thursday on a platform called Wonder, and 2 concurrent tracks of events in the afternoon symposium on Tuesday and Wednesday on Microsoft Teams. All events this week can be joined directly from your browser, and links are available on the event webpage, which I highly recommend you pay a visit. Given the number of attendees, speakers, and events we have occurring this week, we would like to thank you in advance for your patience with any technical difficulties we may encounter. A few housekeeping items before we begin today's session. Everyone is automatically muted, so we hope you'll use the chat function for any comments you have and direct questions for our speakers in the Q&A section. We can all start by typing in the chat from where in the world you're joining us from today. After we conclude today's session at 2 p.m. Eastern Time, we invite you to join our applications community social to mingle and network with the Applied Sciences team and broader applications community. We hope to connect with you there. And now, without further ado, it's my pleasure to introduce our first speaker, Lawrence Friedel, Director of NASA's Applied Sciences program, who will share some opening remarks.
Great, thank you, Katie. Thank you so much for emceeing today. Just waiting for the camera to come up. There we go. Again, thank you, Katie. Thanks for emceeing. And as she mentioned, I'm Lawrence, Applied Scientist Program, and let me add my welcome to everyone for the week's events. I have to say, I love telling people about Earth science applications and really what NASA does in this space. Truly, I think it's one of the best things in government. So we know that organizations make decisions and that many of them have an environmental aspect to them. But many of these organizations aren't necessarily aware that NASA even does earth science, let alone that our research and our information, the data from our satellites can help them. And so that's what Applied Sciences is about. So we focus on getting those scientific insights and that space-based data into the hands of organizations and managers and everyday people who can put them to work doing everything from irrigating alfalfa fields in Oregon to crafting West Nile virus alerts in South Dakota to issuing air quality warnings in Thailand. And what these organizations wind up doing is really, really uplifting to all of us at NASA Earth Science. But really, what's even more vital are the people that make all this happen. It's the people who work with these organizations, who listen to them, who design and run the projects, and they co-develop these solutions together. And it's really the benefits that they create, and it's their sense of service that I really find incredible. And it's those people, and including the struggles that they've had to overcome, that we find especially inspiring. It's people like Carly McClellan. Carly was born and raised in the Navajo Nation, which is an indigenous reservation spanning about 17 million acres in some of the most arid land in Arizona, Utah, and New Mexico. And these days, Carly is a senior hydrologist with the Navajo Nation. But years ago, he was a struggling college student. At one point, he actually even left school to work some odd jobs in Tucson, but he returned. He eventually got his chemistry degree at the University of Arizona. And while working in a lab, he heard about NASA Develop, which you're going to hear about a lot this week. Now, he got involved with Develop and he worked a project back with the Navajo Nation. And he continued on and he helped them really refine a lot of the methods. And today, that application is called the Drought Severity Evaluation Tool. And in fact, it went operational last November by the Navajo Nation's Department of Water Resources. It's a tool that pulls in information from multiple NASA satellites, and it creates maps showing variations across the reservation in terms of drought conditions and all. And so Carly and others at the department there are using it to better allocate water resources, to do it more efficiently, more effectively, and it's also to give out drought relief funds more equitably. So Carly is just one of hundreds of people that we could talk about who are doing this great work, and you'll hear about some of them this week. For example, on Tuesday, I really hope you're going to tune in on Tuesday to hear more about Becky Chaplin-Kramer. She's working with Mongolian goat farmers. These are the people that provide the thread for cashmere. Together, Becky and the others on the project team, they're applying satellite data to help with better rangeland management and more sustainable production, and more importantly, for the livelihoods of the herders. Hope you'll come back on Wednesday, and if so, please pay attention for a story about Denise Moyle. She's an alfalfa farmer out in the Western United States, and she's using a brand new system called OpenET, which is relying on Landsat data to help her and other farmers better irrigate their fields. And please come back for Thursday to hear about this amazing story about Pablo Mendez Lazaro. It's a story about how he and his team set up an air quality warning system in Puerto Rico right before a major dust storm hit the island last year. Now, these are some of the stories, but there's lots more. And so throughout the week, we really hope you're going to be listening for the range of organizations that we work with, the fleet of NASA satellites that are looking back at the Earth, and how we work and some of the projects that we support. And obviously, there's lots more information about our website, appliedsciences.nasa.gov. And so as you're listening, or if you're reading on the website, we hope you'll also be thinking about how you and all the different organizations that you're involved with, how you might use Earth science data and the insights and all. And if so, please contact us with your ideas. That's what we're here for. And so as I'm wrapping up, I wanted to say today is actually a really big day for us in applied sciences for an additional reason, not just the beginning of the applications week. I'm so pleased to announce that today, August 9th, that we're launching our brand new Applied Sciences Strategic Plan. And this is setting out a new set of goals for us for the next 5 years to really further push innovation in the applications, further push our service to society. It's helping us to really think more about how to do greater knowledge sharing about the wisdom that we've gained, as well as to place an even greater focus on partnerships and especially private sector ventures. And so this plan is on our website as well. So finally, I just wanted to say thanks for tuning into our event. I hope you'll see why I love this Applications Week every year. It's really our chance to show you Earth science in action. And so back to you, Katie.
Thank you so much, Lawrence Friedel, for attending and for those remarks. Now, please welcome the Director of NASA's Earth Science Division, Dr. Karen St. Germain, for some remarks on Earth Science Division perspectives.
Thanks so much, Katie, and also Lawrence. Thanks for those opening comments. So I would like to add my welcome to everyone for the second annual virtual NASA Earth Science Applications Week. This is my second year attending, and I'm just thrilled to be with you to hear these stories that you all will be hearing this week. It's going to certainly be a fast-paced and very educational week for us all. I'd like to thank our Applied Sciences team under Lawrence's guidance and those who also worked hard to coordinate this event, as well as our partner organizations and NASA centers that support this important work. So I mentioned this is my second Applied Sciences week. I joined NASA a little more than a year and a half ago. And I did it largely because NASA is unique among US federal agencies and frankly among our international partnership agencies. We're the only agency that has a true end-to-end scope for the Earth. In other words, we invest in new technologies. We build, launch, and operate the spacecraft and instruments that make the observations, many of the fundamental observations of our Earth system. We perform research and science that helps us use those measurements to better understand the Earth system. And then we develop and deliver applications that use that science to improve life on Earth. I can't actually think of anything more satisfying than having a program that runs that whole end-to-end, and it gives us opportunities to do things that frankly others don't have the latitude to do, and so it's a thrill to be in this role. We're at an inflection point in the mission, though. The science of the last 20 years has really settled the question of whether our climate is changing and why. And really, the science of the next 20 years is going to be about understanding how that change is playing out regionally and in time, and how we can put that information to use so that we can actually continue to thrive on our planet, in the words of our decadal survey authors. And I think the key to that is increasing the use of our science and our science applications. And that's a strategic objective for NASA Earth Science Division and frankly for the Science Mission Directorate. As we increase the number of measurements we make, the volume of data we have, and the value of our research, we're always looking for new ways to press that science into service. And that is what our Applied Sciences team does. Each year, we work with more users, and you'll hear a lot more about that over the coming week. We work with more users than ever before across more sectors of the economy in new geographies, parts of the world, and employing new techniques, whether they're new observations from space or new analytic techniques on the ground. And the whole idea is to integrate science and society, and to do so with, frankly, the urgency that this moment demands. So this week, you'll hear highlights of applications of Earth science data spanning the planet and many thematic areas, all presented by our very diverse community, a team which includes everyone from Zoomers to Boomers. I don't think I fall into the Boomer category yet, but anyway, one highlight of the week is, of course, going to be the DEVELOP program. DEVELOP is a 10-week experiential learning program that builds skills and knowledge in a very hands-on way on Earth observations with young professionals. We'll hear from students and recent graduates working on these projects, and we'll have more opportunities to hear from them Tuesday and Wednesday during Flash Talks. We'll also hear highlights from several of our other programs, including Surveyor and RSET, the NASA Valuables Consortium, NASA Harvest, and Western Water Applications Office. Those consortia are a really interesting way to build problem-solving partnerships. So I'm really excited to hear more about those. And we'll hear more about the intersection between applied science and our research and analysis groups. And finally, we'll close out the week talking about ways that you can get involved. So we're going to hear from a lot of passionate people this week, and we're going to learn how science is benefiting our world. And I hope in all of that, you'll find inspiration, you'll spot opportunities, and you'll feel the same sense of urgency that we here at NASA headquarters feel about pressing our science into use to improve life here on Earth. So with all of that, best of luck to the presenters. Have a great week. I'm excited to see the innovation, the approaches, and the partnerships, and all the great work coming out of your efforts. So with that, I will hand it back over to Katie. Thanks, everyone.
Thank you so much, Dr. St. Germain. Oh, there's my video. Perfect. We'll now turn it over to the program manager of the NASA Applied Sciences program, Dr. Emily Silek-Glassman, to learn more about the Applied Sciences program.
Great. Thank you so much, Katie, and thank you all. I'm thrilled to be here. Like Lawrence, like Karen, this probably is my favorite work week of the year. And I'm just so happy to get to talk to you about the Applied Sciences program and where we fit in NASA's Earth Science Division more broadly. If you can go to the next slide. So let's see. So Karen mentioned that NASA Earth Science Division takes this end-to-end approach to Earth science. So I'll tell you a little bit more about those different pieces. So one piece, we develop, launch, and operate NASA's fleet of Earth-observing satellites and instruments. We develop and test scientific technologies. We support the research that advances the knowledge of Earth as a system. And finally, we encourage innovative and practical uses of that Earth science to advance societal benefit. And together, what we're really trying to do is get this global interconnected picture of the Earth and how the changes that we see affect one another. Next slide, please. So there are these different components of the Earth Science Division, the Applied Sciences program being one of them, and they really fit together like these interconnected puzzle pieces. So we have the Earth Science Technology Office developing the technology that's going to enable measurements 20, 30 years from now with new technologies we haven't seen before because we haven't developed them before. There's also the flight element, and those are the folks that develop and launch and operate our Earth-observing satellites and instruments. There's the research and analysis part of the Earth Science Division, which is furthering our understanding of the Earth system. We have our Earth Science Data System, which really these are the folks taking the information from these measurements and making them discoverable, accessible, and usable to everyone in the world to be able to use for their own purposes. And then finally, there's where I sit on this right-hand side in the application space in the applied sciences, where we're thinking about how do we use all that Earth science knowledge and use it to benefit society, and how do we enable people to use that information for their own purposes. Next slide, please. So what do we do? Essentially, within the Applied Sciences program, we're trying to help people apply the insights from Earth science to benefit the economy, health, quality of life, and the environment around the globe. We do that through investments. Many times those are financial investments where we're funding projects, but they also might be investments of people's time and energy and expertise. But ultimately, all those investments, we're trying to lower the barriers to people using Earth science information for whatever their application. We are organized into a bunch of program elements. Each one of these is indicated with an icon below, and you're going to be hearing from the program managers that lead each of these elements, as well as folks leading projects within each of these elements. So we call 5 of them our application areas, and they're generally these thematic groups, uses of Earth science knowledge. So we have agriculture, disasters, health and air quality, ecological forecasting, and water resources. We also have, and I'll talk a little bit about this in a moment, the capacity building program. And the capacity building program is trying to build the ability of people all around the world to use Earth science information in whatever their applications are. Next slide, please. So I'd like to take a moment to talk a little bit about the capacity building program more extensively, partially because this is the set of people who have convened this wonderful week. So a huge shout out to the organizers, in particular, Sydney Neugebauer, Lauren Childs Gleason, and Amanda Clayton. So the capacity building program, as I mentioned, provides individuals and institutions with a whole source of resources to increase their ability to use earth science. So that comes in the form of workforce development, training activities, and collaborative projects. So I'm showing the 3 icons for the 3 parts of the capacity building program below, and I'd like to just take a moment to discuss each of these separately, because I think they might be relevant to different sets of folks listening here today. First is RSET, which is the Remote Sensing Training Program. So these are, well, now during COVID, all online trainings that are tailored for everyone from an absolute beginner, first time learning about remote sensing, to really advanced users of earth science knowledge trying to further increase their skills. So for example, there's a training in October that's coming up on the use of optical data and synthetic aperture radar for crop classification. So that's one of the intermediate trainings, but there are trainings on all sorts of topics happening all the time. There's also the Develop program, which Karen mentioned. So the Develop addresses policy issues through Earth observations in 10-week projects. And I just want to give a huge shout out to all of the developers here today. I'm so excited to hear your talks, especially if this is the first time that you're ever giving a scientific talk. How thrilling for all of us, for you to give the talk and for us to hear your words. Last but certainly not least, we have the SERVIR program, which is a partnership between NASA and USAID to support developing countries in applying geospatial technology to decision making. So we have all of these different programs. They're all going to be represented here this week during Earth Science Applications Week, and I'm just really excited to see everything come together. Next slide, please. So I mentioned that we make different basically funding investments, but I want to talk a little bit more about how we work so that hopefully if you're listening on the call, you can find a way to get involved. So in general, what we're trying to do is we're trying to magnify the value of earth science information. And that might be from NASA's satellites or instruments, but it also might be from information from our international partners, information collected by state and local agencies, really any other kind of earth science knowledge. And we're trying to work on scales from local to global to bridge those gaps between scientific findings and practical applications. And it's this this view that we have with these satellites looking at Earth that allows us to do these amazingly global applications, or to take something that we've done locally and apply it, replicate it to another area on the planet. So in general, we are trying to work in a very user-centered way. Our project teams, our staff, we don't assume we know the answer. We listen to the end user and the people who are going to be implementing a solution. We're market oriented, and this year with our strategy being released, we're really committing to doing more market research to understand how we should be pursuing our ideas most efficiently. We like to have our staff and people involved in our projects lead committees and working groups. Maybe that's locally, maybe that's nationally, internationally. And in general, we're incredibly focused on trying to create substantial and lasting impacts. And for that, we're constantly trying to assess what are the things we should be measuring, what new things should we be measuring, and how do we do that better. Next slide, please. So with that, I just want to tell you how excited we all are that you are here. We're so excited that you're joining us in the mission, and we can't wait to see how you're using earth science information to improve life on our planet. Whether this is your first time engaging with NASA or you've been working as part of the program for years and years, I just think it's amazing that we're all gathered here today. And I really believe that it's through working together with earth science data and knowledge that we can find solutions to our planet's greatest challenges. So with that, I'll just go to the next slide and give you my thanks. Really excited about to see all the talks here today. If you have further questions, please feel free to send me an email. If I can't answer it, I'm happy to find you someone that can. So with that, I will send this back to Katie. Thank you.
Thank you so much for the amazing overview of the program, Dr. Silag Glassman. We'll now welcome two NASA Capacity Building Program interns to the virtual stage, Teresa Perello and Monica Nemo, who've been helping the Capacity Building Program with a series of projects, including researching the history of the Applied Sciences program.
Hello, my name is Teresa Perello, and I am a Capacity Building Program intern. And today we'll celebrate the 20th anniversary of the Applied Sciences program by looking at its history. Next slide, please. This is a timeline of some of the major events that have happened with the Applied Sciences at NASA since NASA's beginning. Over the past 20 years and before, NASA has been doing work and helping and impacting many people through this Applied Sciences work. And these are just some of the highlights. Next slide, please. In 1958, some of the original legislation around NASA allowed for them to extend the benefits of the science to the community, thus starting Applied Sciences work at NASA. In 1960, the first weather satellite, TIROS-1, was launched. It gave us the first television image of Earth from space and proved that scientists could use space to better understand our planet. Over the next 40 years, NASA would launch 7 Landsat satellites, which have become key sources of Earth observations data. However, between these years, Applied Sciences work at NASA was done on a demand basis, with university researchers and local governments reaching out to NASA to work together on projects and have access to data, rather than NASA leading the projects themselves. This changed in 2001. Next slide, please.
Hello, my name is Monica, and from 2001 to 2011, there were initially 12 application focuses, and as NASA Applied Sciences expanded, this led to greater partnerships alongside local, federal, and international institutions to further establish additional application focuses, especially as satellite data became more readily available and free for anyone to utilize. For example, in 2008, Landsat data became free and open source for anyone to use, and as the graph showcases, this data was significantly used more after 2008. And next slide, please. Additionally, there are about 6 funded areas under the Applied Sciences, as well as 3 additional focus groups, where the Capacity Building Program manages 3 program areas, which are Develop, RSET, and Severe since 2011. You will also be hearing more about their work throughout this week. Moreover, over the past 10 years, the Applied Sciences program has become more involved in the planning stages of Earth science missions. Next slide, please.
And that brings us to today. We look forward to seeing the impact of the program over the next 20 years, and thank you for celebrating with us.
Thank you, Teresa and Monica, and we look forward to hearing more about the work you've done this summer in the coming days. Next, we'll shift focus to one of the Applied Sciences sister programs under NASA's Research and Analysis program. I'm happy to introduce Dr. Laura Lorenzoni, Program Scientist for Ocean Biology and Biogeochemistry program, to talk to us about NASA Research and Analysis coastal applications.
Good morning, can you hear me okay?
Yeah, we can hear you all right.
Awesome, thank you. Well, first of all, thank you for giving me the opportunity to talk a little bit about coastal zones and the work that the Research and Analysis program has done, and that it's currently undertaking, and then how that bridges towards applications. So we can go to the next slide, please. Coastal work within NASA is embedded both within the Research and Analysis program, which are shown in pink in this slide, and then within also the Applied Sciences, which are shown in blue. Because of its nature, it really is something that needs to be looked at from both ends. We don't have a particular program that supports it, so it is supported through a variety of core programs like the Ocean Biology and Biogeochemistry program, the Physical Oceanography program, Terrestrial Hydrology, Biodiversity. We can even support it through combined calls that take several programs like the Carbon Cycle Science, the Interdisciplinary call, and also the Terra VMPP calls from the applied sciences side, ecological forecasting and water resources and agriculture have also been big supporters of some sort of coastal focused work. We solicit everything that is NASA or at least ESC wide and research wide through the AROSA's Omnibus, which comes out once a year in February. And that also gives us flexibility in terms of the kinds of topics that we want to focus on. And those depend on the science priority that our community, which is it's you, it's everybody that's listening to this talk, that you identify, because it is a very dynamic area, as we'll see. We really want to make sure that we're targeting the scientific priorities that need to be addressed. Next slide, please. And this is just really pretty to look at. There's been a lot of interest in the coastal zone, not just now, but always. And so obviously that begs the question, what is it about the coastal zone in particular that draws so much attention? And the answer is location, location, location. Humans obviously are drawn to water. We need it for survival. And about 40% of the world's population that's within 100 kilometers from the coast. Waterways are used for transportation of goods, coasts, and that is all coasts, not just the ones with the ocean, but also inland lakes and riverbanks. They're considered aquatic critical zones, which means that they're interfaces where important chemical, biological, geological, and physical processes take place. These are important areas where we have ecosystem services, and so they're important for the population, and that's why they support such high population densities. Because of the important elemental cycles that take place in coastal zones, it is really important for us to understand how these may be changing. And with the different and increasing natural anthropogenic pressures that the coastal zones have had and that continue to have, the biogeochemical cycling, the ecological functioning, and the ecosystem services that they provide continue to change. They have changed. Next slide, please. So understanding the stressors on ecosystems is really critical to sustain these, not just the coastal zones themselves for humans' use, but also ensuring that they remain healthy for the ecosystem and the ecosystem services that they provide, because just of the critical importance that they play. So NASA has done a significant investment in projects that have a coastal focus, both through the research and analysis programs and the applied sciences, as I mentioned in my second slide. I'm just going to provide you with very quick, just 3 examples, but there's just like there are these three examples. There are many. Our investment in coastal zone is really remarkable. One of the first examples that I'm going to mention is the one that you have on your, this is my left, so hopefully it's everybody's left, which has to do with sargassum. And that is work that Cho-Min Hu at the University of South Florida and his colleagues have done, and they've looked and characterized the Great Atlantic Sargassum Belt. And sargassum really has been around for a long time, and it is a critical habitat for a variety of species in the ocean. But since 2011, there's been a significant increase in the density and the extent of sargassum, which now has generated this great belt that extends from West Africa to the Caribbean and all the way up to the Gulf of Mexico. And this increased sargassum concentration has caused significant economic impacts on nations that depend on the beach for tourism and other revenue. So being able to predict the abundance of sargassum has really been critical. And so the prediction part is really what ties it to the human impact, but research has pinpointed a variety of potential reasons why these blooms occur. And so understanding the reason why we have such big blooms is also critical to forecast what may be happening in the future. And it is possible that this is the new normal. And so continuing to really hone into the reasons of why we're seeing these, kind of ecological change is really important. And the work that Dr. Hu and his colleagues have been funded for has come through both the research and analysis side, which is the Ocean Biology and Biochemistry program, and also the Ecological Forecasting program, which sits on the Applied Sciences side. Another example of coastal work, this time focusing on coastal lakes, which are also important for humans, is done by Laura Borgo Chavez at Michigan Tech and her colleagues. And they've been supported through the Interdisciplinary Science program. And so they've been trying to look at quantifying kind of the historical and potential future impacts of climate, changing land use and management practices on the ecosystem structure and function that sits right at the land-water interface in the Great Lakes Basin. And the gist of it is that changes in water and nutrient inputs really change the ecology of the basin. So it is really important to understand how changes up in the land are then going to trickle down to the ecosystems that rim the Great Lakes. And there's also the impact of invasive species, which cause a whole suite of ecological changes, and that may jeopardize some of the ecosystem services that the ecosystem of the Great Lakes provide. The interesting thing about this project, which was, we really liked it, was that it contemplated the robust engagement of stakeholders, and that included getting feedback on the kinds of products that the scientists were developing, and what else could the scientists have missed that would be useful for managers and planners. And we'll come back to this kind of feedback loop at the end of my brief talk. The last example that I highlight, which is on the far right, is one that we targeted and supported through the rapid response solicitation that was specifically looking at the impact and the human influence on ecosystems by taking advantage of the unique, albeit unwanted, COVID lockdown that we had. Bryce Bernard and Maria Giorgio from the State University of New York, they specifically went and examined the impact of lower human activity on Long Island Sound. And that included changes in atmospheric deposition resulting from less cars and less human, basically industrial activity, and then also changes in the land input. New York, much like many other places, remained in strict lockdown between March and June of 2020. And what Maria and Bryce noticed is that resulted in lower concentrations of chlorophyll A in Long Island Sound, specifically in the Western Narrows and some areas of the near shore that usually are really strongly impacted by human activity. This change in chlorophyll likely resulted from changes in nutrient inputs, both from atmospheric deposition and sewage outflow, as well as other environmental factors. These kinds of results really are useful to understanding and relating the kind of impact that human activities have on ecosystems. Next slide, please. Now, change is really inevitable, and that is something that we have to, accept, and we have to come to, realize. Coastal biochemistry, ecology, morphology has changed, and it will continue to change. And so it comes down to really understanding how this change is impacting global ecosystems and how then is impacting humans. Science and understanding the science of change is ultimately really important for coastal adaptation, and that includes adaptation of plant species, animal species, and humans as well. And the kind of research that we conduct at NASA is within both the applied sciences and the research and analysis program is really critical to understand the kind of resilience and adaptation capacity of coastal ecosystems. Without science really discovering and better informing us of how ecosystem functions and how they can be vulnerable to certain pressures, it is going to be really difficult to take adequate and assertive action to make sure to mitigate in some cases or to offset some of those changes. Most critical is the realization that understanding a system cannot be done in isolation. So with 40% of the world's population living in the coastal zone, understanding the complexities of these ecosystems also includes understanding their value to local communities and including such communities in the research process from the ground up. And we've heard a little bit about that already. Not doing this really runs the risk of generating real high value science, but that may not be really incorporated or be useful for decision making, in particular for future conservation plans. Next slide, please. And I believe that is my last slide. This brings us back to the loop. There are many loops in this slide. Perhaps this might be the most important loop, at least in the conversation of coastal zones. And this is the loop between science and applications and back to the scientists. that I think we've done we've done a decent job, at least, at connecting the science and the stakeholder, but connecting back to the scientist is really, 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 really critical. We're trying to build more robust bridges between the sciences and the applications that NASA supports. And this in particular includes the societal capacity building side. We've also heard, and we'll hear more of this week about that. But for scientists, it is really, really difficult to improve and make their science more relevant and useful for ensuring sustainability for coasts, and this, coast as, not just ecosystems, but also humans, without the engagement and feedback from their applied science partners. And so ensuring that this is really a loop is really going to be critical to move forward. And that is, as I mentioned, that is my last slide. I really look forward to hearing very exciting things this week, and in particular, how the research can support the applications and that return to the science to make sure that our coasts and our world in general are used sustainably. And that's it. Thank you so much again.
Thank you, Dr. Lorenzoni, for that amazing presentation. We'll now move into exploring NASA's climate applications with Dr. Gavin Schmidt, Director of Goddard Institute for Space Studies.
Hi, can you hear me?
Yep, we can hear you okay.
Sirens in the background? Sorry about that. So I just wanted to add my my comments to this whole wonderful week of applications with a big push and a plug for decisions related to climate change. Historically, we've very much focused on the use of NASA data for relatively short-term emergencies or for seasonal decision making. But it's becoming increasingly clear, and especially today, some of you will have seen on the news the IPCC report has just come out. This is the 6th assessment report, and it paints an increasingly clear picture, not just of what's happening to the climate, but why it's happening and what we can anticipate for the future in a whole suite of different metrics, not just the global mean temperature, but in flooding events and drought events and extreme weather, extreme precipitation, extreme winds, marine heat waves, a whole suite of different projected impacts, not least coastal flooding because of increased sea level rise. And NASA has been a big part of putting together that data, has been a big part of getting that information out to a broader public. But the release of this report really tells us at NASA that we have to be supporting the decision making that's going to be needed, that is needed already for people who are working with mitigation strategies, people who are working with adaptation strategies, and who are having to make long-term investment decisions related to coastal defenses, water management, crops, building infrastructure. That require a different kind of information, a different kind of applied science, and we've been doing this at NASA, I think, on a slightly ad hoc basis for many years. I know a team at NASA GIS has been advising the C40 group of international cities. They've been advising the New York City panel on climate change. So we've been involved in these issues since, in fact, Jim Hansen famously in Congress announced that global warming was here back in 1988. But as an agency and as a collective focused program on supporting climate change decision making, we haven't yet done that. And I know that there are lots of efforts within the applied science programs already that touch on these issues, but we've never had it as a clear focus area, and I think that that's somewhere where I think in the near term we may be able to do something about that. We're making a great start. Along with the IPCC report coming out today, we have a new interactive sea level viewer on the NASA Sea Level portal that allows you to dive in and see what the regional sea level predictions are for any particular coastal area. Under any particular scenario, including questions of deep uncertainty when it comes to exactly what's going to happen to the ice sheets that we're tracking from remote sensing and through modeling. We have an enormous I think a potential for doing more in this area, and I'm very happy to be working with the team at Applied Sciences to try and elevate our efforts on climate change decision making, and to bring that truly into the Applied Sciences fold. Thank you.
Thank you so much for sharing those remarks with us, Dr. Schmidt. As we are approaching the top of the hour, we will now transition to the Earth Observations user panel. But before we do, a huge thank you to all of our speakers this morning for kicking off the week with such amazing presentations and remarks. In the coming days, we have a packed schedule full of events to learn about the many ways experts from within and outside the agency are using Earth observations to address our planet's most pressing concerns. A quick refresher on what's to come. Each day we'll host plenary sessions on Zoom from 12 p.m. to 2 p.m. Eastern Time, which you can join using the same link that you used to join today. Following the plenary sessions on Tuesday and Wednesday, we have an exciting lineup of flash talks, career panels, presentations, running in 2 concurrent tracks during the afternoon symposium on Microsoft Teams. Today and Thursday, after we conclude our plenary sessions, we invite you to join us at the community social events to network and mingle with the applied sciences community on an interactive platform called Wonder. Again, all events can be joined directly from your browser, and I highly encourage you to attend our presentations and networking sessions throughout the week and visit the event webpage where you'll find the complete, most up-to-date schedule with links to all events. Before we begin our next session, we're looking for a little audience participation. We've posted a poll in the chat to hear your thoughts, so please follow the link to vote in the poll posted in the chat. We'll now begin the second half of our plenary session, the Earth Observation User Panel, where end users and decision makers will discuss how their organizations have applied data-driven Earth observations to enhance decision-making and management practices. I'm happy to introduce our second MC for the day, Dr. Nicole Ramberg-Peel, who will moderate the conversation. Thanks again to everyone who's joined us for our Earth Science Applications Week kickoff event, and I will now pass the mic over to Nicole to introduce today's panelists.
Thank you, Katie, and thank you to everyone who spoke over the last hour. I would like to welcome everyone to the Earth Observations User Panel. I'm Nicole Ramberg-Peel, a fellow for the NASA-developed national program located at Goddard Space Flight Center, and I'll be the moderator for our panel today. As a fellow with the developed program, I have the pleasure of working with end users on a daily basis. Our end users are individuals and organizations that engage with NASA Earth observation data to address environmental concerns across the globe, and this information is used in their decision-making practices. These panelists have worked with programs in the applied sciences, including DEVELOP, SERVIR, and WAO, the Western Water Applications Office. During the panel today, if you have questions, please put them in the Q&A section. These questions will be shared with the panelists after the event. You also have the option to select View at the top right corner of your screen. Selecting Gallery View will allow you to see all of the panelists at the same time. Now, I would like to take a moment to introduce our panelists. Today, we have Tanner Yes, Co-Executive Director with Groundwork USA, Ohio River Valley. Milagros Becerra, a Research Assistant with Amazon Conservation. and Nikki Tully, a PhD candidate from the University of Arizona and member of the Navajo Nation, who has worked with the Western Water Applications Office, also known as WAO. To start off today, Tanner, would you introduce yourself and tell us a bit about the objectives of your organization?
Yeah, hi everyone, honored to be here with you. Again, my name is Tanner Yes with Groundwork Ohio River Valley. We are part of Groundwork USA. It's a 21 city network supported by the National Park Service, which really specializes in environmental sustainability initiatives in urban areas. So because of that, we're focusing a lot on climate change, as you can imagine. And let's be real, just affiliation with NASA gives me some credibility, right? I put a lot of pressure on a lot of partners. We try to pull a lot of levers to get our work done and policy made, et cetera. And so it's been an honor to work with NASA Develop and their capacity building program intern team with our young people. We do a lot of stuff at Groundwork Ohio River Valley. We focus on green workforce development. We have one of the largest youth workforce programs in the country. We do, excuse me, climate safe neighborhoods, which is a climate resiliency program. And then we have all sorts of other education and community development connections. But really what we try always to do is pair practitioners with policymakers with academics. And that's where NASA Develop and the other programs have been so helpful, particularly with climate safe neighborhoods. And it was interesting to hear the last presenter of the first section. We are putting this data, we're putting this advocacy to use here in Cincinnati. And it will be used by policymakers and politicians and so forth when we do our Green Cincinnati plan. And we talk about engaging residents, we do so in an equitable way. So everything we do is concentrated on raising the voices of those who have really not been heard by the environmental and conservation movement. And those are the ways that we do it. Thank you.
Thank you so much for sharing, Tanner. That was great. I can't wait to hear more throughout the panel today. Next, we have Milagros. If you could share a little bit about yourself and your organization and its objectives.
All right, thank you, Nicole, for inviting me to this panel. Yes, my name is Milagros Becerra. I am part of the team of the GIS and Technology at Conservación Amazónica, well known as SACA. This is a Peruvian NGO that have been working on the conservation of the Southwest Amazon for more than 20 years. Our mission is to integrate science, technology, and communities to conserve the Amazon Andes, the most diverse ecosystem of the planet. We promote the conservation as we manage the first conservation concession in the country. Our organization also is member of Servir Amazonia program. Under the scientific approach on this program, it has been possible to expand to other co-development opportunities with key institutions in the sub-region through different projects and services focused on land cover, land use change, ecosystem, as well as drought, fire, and water-related disasters. As an example of this interaction with the Super of Servir Amazonia and the Spatial Informatics Group, we've developed an system early alert based on radar imageries with Sentinel-1. The election of the sensor was because it allowed us to visualize the land cover, even the cloudy seasonality and the Amazon rainforest. However, this analysis that we've doing in the past with optical imagery as Landsat and Sentinel-2 allowed us to understand the dynamics on the land cover and the evolution of the mining activities over important priority areas. This tool, named RAMI, was launched on May of the present year in order to reduce near real-time information of mining deforestation in priority areas such as protected areas, indigenous land, and persistent activity in degraded areas. And the goal of this tool is allowed us to the Peruvian Ministry of Environment and their stakeholders to improve decisions and accuracy of deforestation due mining activities, and finally discriminate the currency of activity considering the new government formalization process, and also to better understand how illegal mining impacts occur on this area. And finally, in the framework of Servir Global, we've been having discussion and interaction with another Earth observation specialist from West Africa and Mekong. Thank you. Thank you, Nicole.
Yeah, of course. Thank you so much for sharing that information. That sounds so interesting. And again, very excited to hear your responses later today. And last but not least, we have Nikki Tully. So Nikki, if you would like to share a little bit about yourself and the work that you're doing, that would be wonderful.
Hi, my name is Nikki Tully, and I'm from the Navajo Nation and a PhD candidate at the University of Arizona. I thought I would start my introduction a bit different here today in sharing the project that I'm involved with. On the screen, you'll see a picture of a dirt road leading up to the house that I grew up in and located in Blue Gap, Arizona. I show you this picture to help you understand the vast landscapes the project I will speak to covers, as well as provide a brief glimpse of what life looks like on the Navajo Nation. Next slide, please. What you see here is a NASA Earth observation image of the home in the circle area of where I grew up in. I was asked to share how the applied science program engagement has benefited the project and communities and how the NASA Earth observations are valuable. However, before I move into the discussion of community component, I felt it was compelled to share a bit about you on a personal level of how the applied science program and the NASA Earth observations are of value to me. The satellite image you see here is on the Navajo Nation, located in an area of over 27,000 square miles. While I was an undergraduate away from home, hours away, taking part in my first remote sensing classes, I began to find data that identified this circle here of the home I grew up in. And being so far away from home, these Earth observations really helped me to develop a sense away from home. And I share this with you because it's the same feeling that I carry today in the work that I do, that the goal is to help people feel connected to the data, to spark interest and to help seek an understanding for the data, to start to create their own analysis and the use of remote sensing and NASA Earth observations, which is exactly what the Drought Severity Evaluation Tool project has done as well. Next slide, please. The Drought Severity Evaluation Tool project here has a number of project team members. There you see the project lead is Amber McCollum from the Bear NASA Ames Research Center, and Carl Lee McClellan from the Navajo Nation Department of Water Resources, whom you've heard a little bit about earlier, as well as Justin Huntington and Britta Dowder from the Desert Research Institute, and myself, Nikki Tully from the University of Arizona. Next slide, please. This slide here is titled Space Connection to Navajo Land. In working with Indigenous communities such as the Navajo Nation, it is important to keep in mind that as data producers, our scientists and thought process will differ from communities we work with. In order to create a sustainable tool to remain relevant in a community, we first need to understand the community we are entering. And this is to give you an idea of where the Navajo Nation is located there on the map in the Southwest Four Corner region of the United States. And in understanding that not all of the technology and developments we create are easily adapted to the area and the people we work with. But it's also a great reminder to us that as scientists, that this is an opportunity to foster partnerships with Indigenous communities that can foster further out of the box thinking to create solutions that are innovative, by first listening to learn and then seeing the opportunities that arise to work together. And there you see, again, a scaling of the traditional ecological knowledge and working with Indigenous communities that can be applied with this data. And communicating the science in a meaningful way. Next slide, please. So the Drought Severity Evaluation Tool is a collaboration of sovereignty and science for the Navajo Nation. It is a NASA WAYO Western Water Applications funded project. And as mentioned before, this importance of co-development was extended in DSET as well, as it was co-developed with the Navajo Nation Department of Water Resources and the Desert Research Institute. And in this co-developed nature, some key components were shown. Can you click for the next slide? So out of these 4 areas of co-development that was shown in importance for the Navajo Nation as an end user is that DSET would need to be a free web application, user-friendly, and a way for time and storage saver to make this analyzing and visualizing data made easier. Next slide, please. And this is the result. Ground truth data from the Navajo rain gauge data from the Navajo Nation was included along with satellite data, model data, and drought indices to be put onto this platform to create the drought severity evaluation tool. And these unique capabilities are all included here to create this aim of combining in situ Navajo rain gauge data with quasi-monthly precipitation totals that are collected through satellite data such as GPM and model data such as CHIRPS, which can produce drought indices like the standardized precipitation index, like you see here in the orange and red colors for this region on the Navajo Nation, looking at the specific region to help the Navajo Nation Department of Water Resources help in developing their drought reporting. Thank you.
Thank you for sharing that and those visuals. That was wonderful to see. And thank you to everyone for taking a few moments to introduce yourselves and your organizations. For our first question, we want to know, in what ways does NASA's freely available Earth observations enable you to fill gaps that aid in your organization's decision making? And why don't we start with Milagros for this question?
All right, thank you, Nicole. Yes, well, how I mentioned before, our GIS unit at Conservación Amazónica ACA works on different strategies for the conservation and sustainability of biodiversity through the use of different Earth observation tools and geospatial information. In the last 7 years, we have been part of the monitoring of the Andean Amazon Project, well known as MAP, with our sister organization, Amazon Conservation in Washington, D.C. In this project, various technical reports have been published on the progress of deforestation due to illegal mining, fires, logging, and other drivers. These analyses have been carried out using high resolution and high frequency imagery, as well as free access medium resolution images as Landsat and the entire dataset available for this sensor. For example, in the Peruvian context, many sources of information also use this product to create deforestation and degradation map for a long period of time. And as well, for example, we are user of this product to identify new fronts and for map. Another example that we use the Fire Information Resource Management, firms NASA. In the past, some colleagues in Bolivia and Brazil has a necessity related to identify the location and the magnitude of active fires that occur in the last 24 hours to increase the monitoring of fires with high resolution and with high temporality of those alerts in order to support firefighters organization. In that sense, we have been developed a fire tracker tool using two sources of information. One of them was firms, and the other one was an aerosol map from Sentinel-5, well known as Tropomi, I think. Another benefit of this exchange of methodologies and the participation in development of application and tools mark a position for our organization as a benchmark in geospatial technology in the region. As an example of it, and as an example of the fire tracker tool, we have been discussion with the applied science team work of the Dr. Douglas Morton about fire forecast and Dr. Katia Fernandez, both experts in climate condition and fire and the new fronts of fires. It allowed us to better understand the dynamics of fire forecast and how these interactions cause fires on new fronts in the Amazon watersheds. This experience for us was valuable to improve the development of the application and tools, as well as to review and understand how the biome was affected by fires. Currently, we are preparing a training for indigenous organizations who monitoring threats of lands to protect the rainforest. One of their requests for them has access to a freely confident and available source of information to detect threats of forests. They have a basic knowledge in GIS, but for that reason, we thought that they don't have the right equipment for monitoring. However, they will use the Google Earth KL extension of firms NASA that is available in Google Earth Pro. So in that sense, it led us to it led to fill the gap to link the indigenous population and the people who monitoring the indigenous lands, and also with the NASA freely available source. Thanks.
Wow, that sounds so amazing. And just the implications of being able to have that, fire tracking software and linking that to indigenous populations. That sounds like, it's been a great experience for you.
Thank you, Nicole. Yes, I think so. That will be really useful for both sides. I think so.
Great. Next, Nikki, if we could hear from you and hear, in what ways does NASA's freely available Earth observations enable you and your work to fill gaps that aid in your organization's decision making?
Yeah, so for the organizations that are in partnership with DSET on the Navajo Nation, I like to give examples from two departments on the Navajo Nation. The first is from the Department of Water Resources. One of the main concerns in living in this vast landscapes that is of interest with DSET is concerning drought. So for the example of how this data is filling the gap using NASA data with the Water Resources Department is helping the nation with addressing its sovereignty over water. So this is in helping the staff and the opportunity to create an analysis to help with drought reporting that aids in making more informed decisions. For example, these decisions could be used in helping to make informed decision makers on drought relief dollars and allocations and so forth, and connecting the ground data with the satellite data, as was mentioned, and using the rain gauge data that is there located physically on the Navajo Nation, but also satellite data. And with DSET, you have this opportunity to look at various regions and communities that help to create a more in-depth analysis of it. And in the case of another group working with DSET on the Navajo Nation is the Navajo Nation Climate Change Group. One of the points of the Navajo Nation Climate Change Vision Statement is that they have this overall goal to prepare the Navajo Nation to adapt to a changing climate and implement strategies that will preserve and enhance natural resources to provide a resilient future for Navajo communities. And so in one way, in helping them further reach their mission is to educate the public. And so by first learning them how to use the data and then taking that information to share it with others is one way that this information is filling the gap by creating that informing the public that this data is out there, but not only ending there, to help other people understand how to use the data to further engage this innovation to create this more efficient and livable communities, which is another part of their overall mission statements. And so in filling the gap and creating this reliable analysis is really, with DSET, is really to help decision makers determine these different drought indices and other precipitation indices, and using satellite data to move these great analysis forward to inform these communities, again, to further enhance that understanding of the data. And again, to mention the unique capabilities of DSET, which is really unique to this project and working with an Indigenous community, is that you have the local data intermingle with the satellite data, but also that there's these boundaries that are included in DSET that look at these smaller communities and agencies and mountain ranges to really create these specific community needs and understanding and using the data to answer their questions. And in that way, that is filling the gap in certain areas that haven't been able to look so narrowly at by using this type of platform.
Yeah, and I think that link, with actually like reaching out and working with the community, showing them, what data is available, that's so important. So thank you for sharing that. And next we have Tanner.
Right. I think Nikki said something pretty important last time. To create a tool or engagement for a community or anything, you have to know the community. And so we know these things are happening, right? Especially in our communities of color and or our low income communities here in Cincinnati or across the nation. I just threw up Groundwork USA's Climate Safe Neighborhood dashboards in the chat, so you can see how NASA develop and NASA data is being used to help us tell these stories, because we know if you live in a community like this, you know that you might be 20 degrees hotter in your neighborhood than on the other side of town because of tree canopy or impervious surfaces. You know that your basements might be flooded more. You know that landslides might be happening more in your neighborhoods. You know that asthma rates and mold and all these things that come with climate change might be affecting you more than other places. Therefore, we try to look at a more nuanced approach to climate change resilience. And that's what we really advocate for. This data and this help has helped us to create the region's first ever neighborhood scale climate resiliency plan. It really zooms in block by block on opportunities, and again, asking for things that make sense and that are proportionately solution-based for communities who have to bear more of this. And that could be cities like we're concentrating on, but of course, coastal areas or whatever it is that we're talking about. It's not just about gross emissions. It's about the right use in the right place in the right community so that these things are accepted, they're aesthetic, they make sense, whatever it may be. And we all know one side of that story here at Groundwork, but the data and literally painting the picture for policymakers and our government institutions and other partners, that's been able to fill the void for us.
Yeah, and I think that, that really interesting point that you brought up was that nuanced approach, right, to that climate resiliency plan, not just like a blanket approach. So I think that that's, a very interesting perspective to bring in. So thank you for everyone for sharing how your organizations utilize NASA Earth observations to inform your organization's decision making. But Nikki, Tanner, and Milagros, can you please speak to how your engagement with the applied sciences sparked new ideas or methods for you to leverage Earth observations in other parts of your work? And Nikki, if we could start with your response for this question, that would be great.
Yeah, thank you, Nicole. I really did appreciate this question because it kind of helped me look to internally to kind of address this question. And so I'm in the middle of my PhD program right now, in the midst of solidifying my research. So the work with the applied sciences has helped me to look further to see the linkages that can be made between the Earth observations and the work happening on the ground. In 2020, as some of you may have read throughout the news globally, the Navajo Nation was hit pretty hard with COVID-19 across the nation. And in this wake of the virus, the pandemic on the Navajo Nation, there was this great renewed highlight of water access across the nation and looking at what the water access and water quality look like, which sparked a further curiosity for me, being there from the nation, but also being a PhD candidate, looking into further how the Earth observations could further aid in addressing the real-time water issues on the Navajo Nation. And so in this question, what it did is it helped me create to look further to see how this might be able to be done in creating solutions, assuring that citizens could have safe drinking water for home agriculture and livestock use. On the Navajo Nation, there is a huge water hauling population that relies on what is called permanent watering points and temporary watering points, as well as livestock wells that are dependent upon for their livelihood. And so in 2020, this group called the Water Access Coordination Group came about, which was addressing the immediate needs of water access and water quality. But what sparked for me was to look further into looking at that current real-time work. How might that be connected to Earth observations in a slightly different way, to begin to use remote sensing to help to further understand the water access and water quality issues, to look at a newfound depth that is yet to be explored, and developing further again on those ideas of a changing climate that could be analyzed, intermingled with understanding the water quality a little bit more, but also looking into this water ratio and population density, and looking at a vast landscape with a lower population, and how remote sensing might be able to aid in that sector.
Wow, thank you so much. That is so fascinating that you've been able to do that and make those connections. And wow, that is great. So next, Tanner, would you like to share?
Right. Well, the thing that's really been helpful is that it's given us the opportunity not only to kind of democratize this data, get it in the streets, into the hands of residents. It is the ammo that we need to arm ourselves for advocacy to make the argument for all of these changes that we want to see made, whether it's tree canopy or policy or sewer systems or whatever it may be. But the really cool thing about having the data and seeing is that you can say, especially as it relates to our youth and residents, let's go a step further. So for example, our youth, as part of our green workforce development programs, are certified in water quality monitoring and collection. And we can zoom in yet again, if we know census tracts, if we can look at city blocks or whatever it is with the data that we have, but then get real individual data points. And we're doing this across the city and trying to go even deeper with things like air quality. And so if we have, for example, residents that we're trying to galvanize around the air quality initiatives, we do laps around the neighborhood or whatever it is, again, we're sinking deeper into the neighborhood. And all of this happens because we have a starting place with the NASA developer, the Earth observations team that allows us to, again, jumping back to a previous question, prioritize. Okay, we know that it's 25 degrees hotter in this neighborhood than another one. Let's dig in to really see what's going on there.
Yeah, that sounds fascinating. And like being able to actually, collect those, in situ data points, that can make a huge difference. All right, and last but not least, Milagros.
All right, thank you, Nicole. Well, from my perspective, I am geographer. So going through this kind of analysis and be part of this kind of effort for me is really stimulating. For example, in the past month, as you know, in our organization, we make a lot of analysis with regarding the land cover, but having analysis with another perspective, for example, water resources and how the water disaster affected for me is really useful because I can interact with another thematic area with another perspective. And also, and for me as well, having this interaction with the applied science team is really useful because we can exchange data sets, exchange methodology, reviewing the previous methodology that we developed to analysis in the Amazonia. So I think for us it's really stimulated because we have an horizontal exchange with scientific and non-scientific as well. For example, we exchange data sets about logging activities in the progress and how the driver deforestation occurred there. So as a result of it, we we publicate a scientific article. So for that reason, we increasing the studies and the knowledge of the Amazonia as well. And also it was able to increase the knowledge from another stakeholders in not only for Peru, it occurred for Colombia and Ecuador as well. So I think it's everyone can win in this kind of interaction. Finally, we lead many trainings in Google Earth Engine. So I think this kind of cloud computing and this kind of tools could be the next step, not only for the Earth observation, for all the analysis that have to involve analysis not only in the Amazonia region, that many analyses that occurred for many resources that I think for that reason I think everybody can win in this kind of interaction with the applied science team and the applied science program as well. Thank you.
Yeah, and that's it's really interesting, and it's great that you are able to work in a way that does incorporate and involve both like the applied sciences and your stakeholders, and like you said, it's a win-win for everybody when that happens and you can share that information. Okay, so now we have a lot of students and early career folks joining us today. from a broad range of disciplines and backgrounds. What advice do you have for them as they start their careers and start to explore how remote sensing and Earth observations might play a part? And for this question, Tanner, it would be great if we could hear from you first.
Right. Well, this is a perfect example. And I'd say for anything, but especially science, it's getting out of your comfort zone and learning how to communicate with the population or the area or whatever it is that you're working with. We've had dozens of young people, high schoolers, who never would have thought they'd have the chance to work with NASA this summer, all of a sudden add that to their resume. And who are the best messengers, who are the best advocates for this type of work? Certainly in our mind, it is young people. So in the landscape of research, locally or nationally, we see a lot of amazing work, but don't often see the authentic connection between researchers and communities that goes beyond just, hey, let us study you, or let us take pictures of what's going on via satellite or whatever else. I think hooking up with someone like Groundwork or whatever practitioner on the ground or nonprofit or advocacy group or whatever is super important. And to suss out, are they going to have action? Are there actionable items that you can hook up with? And how can you connect your research or your interests to needs on the ground, especially as it relates to quality of life? Because as we are trying to change hearts and minds, especially here on the ground, as it relates to climate change or policy, we need to connect these things to what people care about, whether that's income or, again, electric bills because energy is so high, or whatever it may be. I hope that you pair your interests in your research to things that are going to help people out. And to do that, you need to take the time to get to know them, right?
Yeah, and I think that, as somebody who has spent a lot of time, in academia and research, it is something where it's so easy to get focused on the technical aspects of your project and the research and the data. But, really making those meaningful connections with the communities that you're working with, that really can make a huge difference. So I think that point is something, that really can't be stated enough. So I think that was great for sharing. Thank you. Nikki, if we could hear from you next, that would be wonderful.
Yeah, thanks, Nicole. And I really appreciate what Tanner said, and just want to echo again his words about communicating authenticity and caring about the work that you do. And like you just mentioned, that sometimes the technical nature can kind of outride the rest of them, but just understanding the strength and diversity that is there. And so to these people that I am, the students and early career people, I would suggest to go in with the mindset that the remote sensing and Earth observations can appear in your work in the most unique ways, and that the diversity that each of you all bring can play a key role in highlighting the unique ways that the data might be used. We can all look at the same exact satellite data, but an atmospheric scientist, a hydrologist, community member, educator, environmental physicist, or a policymaker can all see that same data very different. And so just like each rotation impacts the detection and monitoring of the physical characteristics of an area for remote sensing and Earth observation, I would say that each of you students and early career folks also have an impact on how the data is seen and is analyzed through your own lived experience that includes your home environment, your schooling, your community, and your specialty and interests, and so forth. So I would say that it's possible to share a perspective and present it in a way that others may not have seen it and can be valued in a project. So overall, I would say don't underestimate what you can contribute into this network of people involved with remote sensing and Earth observation.
Yeah, again, these are all such great points. But yeah, I agree. I think that everyone has these different backgrounds and interests. We come from different places and cultures, and all of that has such, an impact on how, like you said, we view like the same data set. So I think that, taking advantage of that can, really offer a lot to the field. Wonderful. And again, Milagros, if you would like to share your thoughts, that would be wonderful.
Yes, Nicole, thank you. And yes, I agree with Nikki and Tanner about their thoughts, because it's really important to communicate the study that that we're developing. And if I have to answer these questions, well, I think in nowadays there are many access to a large amount of geospatial resources and information. So I recommend for the people who are starting their career, who identifying which are the input tools and most useful sources of information for the field that you want to focus. And in that sense, we want to work and thinking that what are the resources that could be freely and available to have a sustainability in our analysis that been developing. Another, identifying a key person who could be a subject, who could be an expert on the subject that you are interested. That could be a guide and help for your understanding and your studies as well, and understand the complexity and knowing the programming language. Another thing is knowing the programming language, because in nowadays, every cloud computing, every tool that we've developed, we have to know the programming language as well. So understanding those analyses, on understanding those tools will help you for everyone that want to start. And also don't forget the analysis that we do at a geographic level, at the territorial level, and the social component is really important. Understand every field that we've developing as a scientific earth analysis. We have to understand not only the programming thing, we have to understand what happened in the real life to continue increasing the studies and increasing the analysis of that. So that's my recommendation.
Oh, so many additional points that were great, researching these products that are freely available that you can learn to use, and, finding someone who can guide you and a mentor, as well as learning, what are the analyses and programming languages. I think that's all really helpful. And hopefully the people that are on the call that are starting their careers or transitioning into this career, you take these points and you do learn from them, and hopefully hold on to some of them, because it's really great advice from everybody. Thank you. So we do have a little bit of extra time, and we do have an additional question that we would like to give our panelists a chance to answer. And that is, what advances do you think are necessary to help more people benefit from Earth observation data? So if we have anyone who'd like to answer that question, that would be wonderful. And maybe we could start with Milagros for this question.
Okay, thank you, Nicole, again for leading this panel. Well, thinking in these questions is one of the my idea that I became early. It's that, for example, developing this kind of program. For example, NASA developed Servir Amazonia, Servir Global, and the other kind of program will help you to interact the Earth observation analysis with the people, with the village. So I think having this kind of program will increase the knowledge of the main resources that we're discussing today in this panel, and also um, reduce the gaps, reduce the barriers between one of the one of not only for scientific. They have to, in those kind of analysis, they have to be understandable for every person that want to make a decision. For example, we are really close with policymakers, so they don't understand the Earth observation at a high level, but they understand the results. So we have to develop this kind of analysis, but in an easy way that the decision makers can make the changes based on our analysis. So that's my response.
Yeah, and I think that ties in so well with some of the answers from the previous question about science communication and making sure that, you know, we are getting a lot of people involved and, like you said, breaking down those barriers. And I think that ties in very nicely with that previous answer. How about Nikki? Is there anything that you'd like to add to this answer here?
Yeah, so in going along with just what Milagros had said about breaking down barriers, there's a couple of things that I feel that are necessary to help more people benefit from Earth observation data. And I feel that one thing is that informing people that the data is out there. And once that informing the data is out there, how can we help people understand how to access this data in a meaningful way and in an efficient way? And in that way of helping and informing and understanding the data, how can we help people feel confident and connected to the data that would be beneficial to them in seeking out the Earth observation data that they're interested in to answer their questions? And I feel that through creating more platforms like DSET, which was highly based on the end users' guidance of how DSET could be used, that could simplify the method to access and analyze this data in a way that saves time and storage, but also with resources. And so, for example, with DSET, one thing was we really hope to help reach those end users in a way that they would feel confident in using the tool. So a user guide was created along with videos, and that was to specifically address the communities we were working in. And so in other projects involving remote sensing and Earth observations, there's those opportunities as well to look to the communities of how they might see that is best fit to them to engage with the data.
Yeah, that sounds like you've, you know, really put a lot of thought into like how you actually do this, how you connect and how you bridge it and like creating these user guides and things like that. So that is so amazing. Thank you again for sharing that and for adding on to that previous answer. And again, you know, all of these for people that are on the line thinking about how you're integrating NASA Earth observations into your work. You know, these tips are just so amazing. So thank you. So last but not least, Tanner, would you like to add anything to this question? Tanner, it appears that you are muted.
Got it. Thank you. And I'm in total agreement and wouldn't presume to know how technically necessarily tell you how to do that. But I think there's a question of marketing. NASA is such a powerful, hip brand. And I know that staff and capacity has only reached so far, but as you have done with us here in Cincinnati, as it relates especially to youth, I think connecting people to you and kind of demystifying that gets to the data and all those great things that Nikki was talking about. So I'd say just a little bit, again, out of the comfort zone into the kind of the marketing realm.
Great. And yeah, I think that, thank you so much for everyone sharing that. I think that information is so helpful. And it seems that we also have some questions in our Q&A that we're going to go ahead and ask. So the first one, a question for all three of our panelists. Is there one thing that you had to know that the applied sciences community could do better? And what would that be? And for whoever might want to answer this question first, feel free to unmute and do so.
I feel like one thing that might be helpful in answering that question is, as scientists and technical people and that kind of nature, as we're going into communities, I think we often get stuck in that kind of frame of mind where we have these great technologies and solutions, and we've been brought up so highly in academia and are in our workplaces that it could be so easily to go into communities to feel like we have all the answers. But I think if we stop and take time to first listen to the communities that we're working with and understanding what their needs are, that meeting point of tailoring the tools to further meet the needs of the communities could be beneficial. And again, finding that strength and diversity that we might not have otherwise found if we had just gone forward in a technical nature without that citizen component to the tools.
Absolutely. And for our other panelists, is there anything else that you want to add to either, on a similar vein to what Nikki was saying, or if you have, a different perspective that you would like to provide?
Now I will jump into the technical, I guess. One of the things that we beat our head against the wall around here in like a tri-state region, over 70 jurisdictions just within a few miles, is the data doesn't always link up because of how it's collected or what year or what instruments, blah, 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 blah. That has been a frustration and I imagine it's national and internationally, that opportunities are missed because of that. So if you can just become the authority and tell everybody how to do it, that'd be great.
That's a lot of pressure, Tanner. Milagros, is there anything that you would like to add?
I think both Nikki and Tanner have great points. We can answer this in a technical way or in a more institutional way, but I think Earth observation have made big advances in the last 30 years, I think, because in the past we don't have any this kind of tools, and also the geographic information system help a lot of, because they can answer and you can manage your project since your computer, and then you can take actions. One of the Earth observation or the geographic information can't answer is when you go, if you don't have the information, if you don't have the basis, the basic information in any kind of the field, for example, water, for example, fire, tracker, another, you can understand. For that reason, it's really important go through the field. And for example, if you study the manglers in another, for example, in Servir Amazonia, we have a study regarding to mangroves in Guyana. So in there, if we don't go through there and see how they work and how they can make a major effort, we don't understand. We couldn't bring a solution for monitoring. So for that reasons, I think it's really important to understand both not only the geographic and go in your computer, we have to understand how the science works. So for my understanding, we have to understand each field of work to have a better solutions and for bring a better application for monitoring those kind of activities.
And you really started, both you and Tanner really kind of started actually answering the second question, which was a really nice segue. So if there's anything that anybody would like to add or any additional examples that you'd like to provide, similar to what Milagros just did, but are there examples of when the NASA Earth observation data products are unable to assist the community? So, have there been examples of when satellite observations may not be true to those, reality on the ground, which is what, Milagros started talking about. So if there's anything that anyone would like to add about that might be helpful for the audience, please feel free to chime in.
I can jump in and just say that as far as the data that's freely available, it has helped us a lot to go that extra step, whether it's water quality, air quality, and really dig into the individual data units and so forth, because the census block or the Environmental Protection Agency's environmental justice screen tool might not get into that level of data. So you're going to find things that are worse otherwise that is just not available through this open source.
I also would like to add a little bit onto that with the NASA Earth observation products unable to assist in communities. I feel that, again, going back to DSET, one example to give in addressing some of those issues of remaining true to the reality on the ground is that unique opportunity with the intermingling of the ground data that is being collected simultaneously in conjunction with the satellite model data to kind of see those aligning factors. And whereas before in these types of platforms, the Navajo Nation might have been one pixel, but using DSET and as a spinoff of Climate Engine, you're able to narrow down more specifically at those regions to where that one pixel is now being able to be broken up into identify those drought indices to the 110 communities on the Navajo Nation. And that's where you're able to see more specifically those results of the model data sets and the indices that are being shown a little bit more clearly by using those types of platforms and using those different types of boundaries that might have not otherwise been available in those types of specific forms that have been developed in that platform to show that reality of the ground and the satellite data coming together.
Thank you so much for everyone answering those questions. And we have one last question that we're going to pose. This comes from Lawrence Friedel. He said that the Applied Sciences is putting together a report to capture the knowledge and wisdom we've gained from doing earth science applications all these years. To the panelist, for someone who is just starting out with earth science applications, what advice would you give to them? So someone just coming into earth science application work.
I would suggest that one thing that has been really highly beneficial to me is that whole networking and mentoring component, that there's a lot of people who have been doing this for far longer than I have been involved in this type of project and work. And when you start to reach out to people who you might just happen to Google or who you're introduced to at different conferences or even in virtual platforms like this of people speaking, people are really welcoming to the reaching out of people who are barely entering this type of field. I have found in developing that networking and mentoring, I feel that would be highly beneficial to somebody coming in recently to start to understand through other people who they might further reach out to reach what they're really specifically looking into, and also develop maybe even further opportunities to them in becoming more involved in the work that is being done.
That's a great point, and I think that echoes some of what we heard before too, with like that idea of a mentor. And Milagros, I saw that you turned your camera on. What would you like to add to that? We'd love to hear from you.
Yes, yeah, well, we have an experience about it because we developed a tool or an application regarding Earth observation. So also I think I agree with Nikki, because I think the mentoring component is really important, because when you start a project, you have the general idea about your project, but you don't have the right path to start your work. So I think having an exchanges or participating in hackathon as well could be a good solution to see many methodologies or many ways to start your project. But in order to prepare the good way or the good path for your project, you have to start a mentoring component, and also don't frustrated with the project doesn't start in an easy way, because at the beginning it's going to be really difficult for someone that is starting a new project. But at the end of the project, you're going to see the solutions. And also in Earth observation, there are many places or many groups that of exchange, and participating in this kind of exchange will be useful for both, for the person who participates to receive feedbacks and the person who leads the projects. So I think it's really important to have an exchange, places and interaction with another GIS especially.
all of that. And just quickly, I think, again, encouraging you to get out of maybe the traditional lanes, and you will really look like a rock star if you go work or present to groups that have no idea what this stuff is. And maybe rudimentary stuff to you will be pretty groundbreaking for them or their industry. So try to think outside the box in that way.
Yeah, and I think that you know, those last two comments about both the fact that that process of doing this kind of work can be a challenge, but working with people in this field that can guide you and make it really meaningful is important, but also getting outside of, you know, potentially that comfort zone, that box that you know. I think that's a really, you know, a really good point to bring up, and hopefully people take that to heart and actually, you know, use that when they move forward in their own work. So thank you so much to all of the panelists again for sharing your experiences integrating NASA Earth observations into your work and decision making. At this time, we are going to adjourn, but we encourage everyone to attend the other Earth Science Applications Week presentations that are occurring over the next few days, and even join the Applications Community Social on Wonder from 2 to 3 p.m. Eastern today, where you can join the Applied Sciences team and the broader applications community in a fun networking social. Links for all of our events can be found on the Earth Science Applications Week agenda, and we hope to see everyone more throughout the week. Bye, everybody.